Today's lesson will focus on the solutions to the questions in Lesson 3. If you recall, Lesson 3 focused on multiplication of a monomial by a monomial. And in Lesson 3, we covered terms like monomial is an algebraic expression made up of one term. Then we discussed what a term is. A term is made up of any number of factors multiplied or divided together. And then an example of a squared multiplied by a to the exponent 4, we were shown how to derive or to solve, where you break down or you expand each term to derive the final solution. And there was also a method that you were taught and you were asked to remember. When you multiply two or more monomials, you multiply the signs, you multiply the constant factors, you multiply the factors with the same base, as shown in this example. So again, you need to know that you must multiply the sign, you multiply the number, you multiply the variable by adding the exponents of same variables. The questions that were given to you ranged from 2.11 to 2.110, and then from 2.2.1 to 2.2.20. Now, as shown below this, here, these are the final solution for the questions above. These are the final solution for the questions above. I am now going to show detailed working for some of the questions, not all of them, but some of them. And we start off with question 2.1.1. In question 2.1.1, you were given, let's quickly go to the question, a squared multiplied by a cubed. You were asked to write out the following in expanded form and then to simplify. So we know expanded form means if you're given a squared is a multiplied by a. A cubed is a multiplied by itself, a multiplied by a multiplied by a. Now this is referred to as the expanded form. Now another method would be a times a, we know is written as a squared. And a squared, if you add plus 3. And that's how you derive the solution a exponential 5. So in this bracket, you have a multiplied by a. So it's a to the power 2. Here, it's a times a times a, which is 3. And therefore, you add 2 plus 3, which gives you a to the exponential 5. If you count how many a's there are in this bracket, there are 2. In this bracket, there are 3. So 2 plus 3 gives you 5. Similarly, if you look at question 2.1.4, you were given d to the exponential 6 is multiplied by d. Again, in an expanded form, d to the exponent 6, you write out d multiplied by d all together 6 times. All together 6 times. Multiplied by d. Again, if you count how many d's there are in total, there's 7. And this should have been a d. Let's correct that quickly. There we are. And again, if you add the exponents of each of these d's, which is 1, you get 7. So this solution is d to the exponent 7. The next question, which is 2.1.7, and 2.1.7, we were given this x cubed multiplied by y squared, which is further multiplied by x squared multiplied by y cubed. So when you write this out, you need to focus first on rewriting the letters in alphabetical order, meaning x then y. You see, you rearrange this x then y. And then you focus on this. You write down x, like I did here. And then you look at the exponent of x. In this case, the exponent of x is 3. And here, the exponent is 2. So the process or the method is you first write down the base, which is x. And then you add 3 and 2. So 3 plus 2 gives you x exponent 5. Then you move on to the y. Again, the base y, you write down as is over here. And then you add the exponent of y, which is 2. You add it to 3. You also get 5. So the final solution to this question is x exponent 5, y exponent 5. The next question, 2.1.10. Now remember, no matter how many variables are given to you, there's no need to become confused. The first step is to write out the term. In the term, the variables you write out in alphabetical order, meaning in this case, it's P, Q, S. And in the second bracket, this term, you also rearrange. You rearrange it such that it's following the order P, Q, and S. Then the first step, you focus on the number contained in the expressions. In the first bracket, we have 4. The second bracket, we have 12. So 4 multiplied by 12 is 48. Then you move on to the first letter or the first variable. The first variable in the bracket is P, so you write down P over here. What is the exponent for P? When a variable is written on its own, the exponent is always 1. So just for this example, I will write it down or type it and show you that it's 1. So the exponent here is 1. The exponent here is 2. Therefore, 1 plus 2 is 3. So now we have worked out 48, P, exponent 3. Then you move to the next variable, which is Q. And in this case, you write down Q. You look at the exponent. For Q, it's 3 and 3, which gives you 6. This is an important step. 3 plus 3 gives you 6. Then the last variable, which is S, The exponent here is 2. And again, when there isn't a value shown for the exponent, it's always 1. Just remember, it's always 1. Like so. So when you write down s, you now add the exponents of each of the variable s. 2 plus 1 is 3. Therefore, the final solution for this question is 48 p cubed q to the exponent 6 s to the exponent 3, or s cubed. Question 2.2.1. Now, if you look at 2.2.1, you were given negative a exponent 4 multiplied by a to the exponent 6. So using the expanded notation or expanded form, you write the negative sign outside the bracket. And within the brackets, you expand a to the exponent 4 in this way. This is a to the exponent 6 expanded. So remember here as well, it's not shown, but the sign is a positive sign. Therefore, a negative, we know, multiplied by a positive is always a negative. And thereafter, it's simply writing down the common base, which is a, and then adding each of the exponents, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which gives you a final answer of negative a raised to the exponent 10. Remember, I'm only working out a few of the questions, but all the answers are shown in this block here, in this block. The next question, we have negative k exponential 5, positive k to the exponential 9. So similarly, you multiply a negative by a positive to get a negative. And you count how many k's there are in the first bracket, you add it to the second, you get a total exponential value of 14. Question 2.2.10. Here you were given negative a cubed b to the exponential 6, which is multiplied by a squared b. Again, you first work with the sign that's just outside the bracket. Negative multiplied, there's the multiplication sign. Negative multiplied by positive is negative. A cubed multiplied by a squared gives you a to the exponential 5, and b to the exponential 6 multiplied by b, and as I explained, this exponential is 1 to give you 7. Then we move on to an expression that has 3 variables, which is similar to this question. Outside the bracket, we have a negative 5, and in this bracket, we have negative 3. Remember, a negative multiplied by a negative gives you a positive. 5 multiplied by 3 gives you 15. You write down each of these base, namely x, y, and z, and then you analyze first x, then your y, and then your z. So 5 plus 2 gives you 7. There is no other value for x, for y. So you simply write down y to the exponential 6 as is. Z has an exponential 1. So let me just complete this. Z has an exponent which is 1. And again, 1 plus 1 is 2. And therefore your final solution for this question is 15x raised to the power or exponent 7, y to the exponent 6, z squared.